What's up, YouTube? It's your boy Rod, the tech guy, and today is going to be my first networking video. We're going to be going over routing, okay? Alright, so what is routing? Routing is a process of determining paths across a network for data to travel from a source to a destination. It ensures data packets reach their intended destination efficiently. Alright. How does routing work? Okay. Routing uses routing tables. Routers store known paths to destinations in tables which can be updated dynamically or manually. My personal favorite is, dynamic, but hey, we'll get into that maybe in a different video, okay? We're going to end off on static routing for this one, all right? Routing uses different routing protocols, such as OSPF, RIP, to share information about a network topology and available routes, okay? Routing uses different path selections. Okay, so routers evaluate routes using metrics and select the most efficient path for data packets. So let's say, for example, have you ever opened up a GPS, right? And on your GPS, if you're trying to get to your destination, the GPS usually provides different routes that you can take. Routers work the same way, okay? Provides different routes for data to take, okay? It helps with packet forwarding as well. Once a route is chosen, packets are forwarded through the selected path to reach their destination. Okay, so why do we have routing? Okay, we have routing for efficient data transfer. Routing routes packets along the best path to minimize travel time and congestion. It helps in connectivity across networks by enabling global communication between different networks. Whoa, that's a big word for me. Facilitating global connectivity, okay? It assists with scalability. It supports network growth by managing increased traffic without overloading infrastructure. It also assists in reliability and redundancy. It provides alternate paths for data, ensuring stability and uptime even if one route fails. Networking is all about redundancy, guys. All right, so here you see we have a couple of different topologies we can go ahead and take a look at. So we do have a source device. We have router 1. Router 1 is going to check its routing table, check its destination, and it can either go via its next hop. Router 2 is going to repeat the same process as router 1. It's going to check its routing table, check its destination, and then go to router 3. Or it can skip all of that and go directly to its destination. And naturally, the same rules apply for router 2 and router 3. So it all just depends, right? So what does it depend on? The routing table, okay? As you can see, here is a routing table breakdown. You can see a C, an L, and 2 S's down here. These are going to be your these are going to be your different types of routes, all right? So C is going to be connected routes, L is going to be your local routes, and S is going to be your static routes, okay? This number in here, this 1/0, that's going to be your administrative distance. And the IP address at the end is naturally going to be your next hop, followed by the destination in front. So it'll be destination, usually your subnet mask, and then next hop. But we'll get into that. We'll configure one on Packet Tracer. So different routing metrics. Routing metrics are values used by routers to select the best path for data packets across a network. They're common metrics, which include hop count, bandwidth, delay, reliability, load, and cost. Purpose. Metrics optimize traffic flow by prioritizing faster, less congested, and more reliable routes. Different routing protocols use one or multiple metrics to calculate the most efficient path. RIP uses hop count. EIGRP uses multiple metrics. Alright, so types of metrics. As I said earlier, there's hop count. So this counts routers, hops on a route. Lower counts indicate shorter routes. There's bandwidth, so measures link data rate. Higher bandwidth supports more data and reduces congestion. There's delay, calculates the time to traverse a route. Lower delay means faster transmission. There's reliability. It assesses failure likelihood. High reliability means fewer failures. There's load, measures current traffic. Lower load avoids congestion, and there's cost. Custom metric for prioritizing routes based on policy or performance. All right, moving on to the next topic, administrative distance. Administrative distance is a metric used to determine how reliable a routing source is. It is represented by how trustworthy a route is on a routing table. Routers may have overlapping routes within a network, and it uses administrative distance to decide which route to take. All right, so as you can see, these are some default administrative distances. So we've got connected and local routes with an administrative distance of 0. We've got static routes with 1, EIGRP summary route with 5, external BGP with 20, internal EIGRP with 90, IGRP with 100, OSPF, my personal favorite, with 110, ISIS with 115, EIGRP with 170, and IBGP with 200. All right. So to get a little more in depth when it comes to connected routes, local routes, and static routes, connected routes are routes automatically created by routers for networks directly attached to their interfaces. Okay, so if I took a router and hooked it up to another router, they would have a connected route. They're directly connected to each other. All right. So there is an automatic addition. When a new network is directly connected, the router instantly adds it to its routing table. Connected routes generally have a higher priority than other types of routes, ensuring direct access. Since they're direct connections, no extra configuration or routing protocol is required for these routes. So connected routes are pretty simple. Next thing is going to be local routes. Local routes are representing the router's own IP addresses assigned to its interfaces. These routes are added to the routing table as soon as an interface is assigned to an IP address. They allow the router to identify its own addresses for communication within the network. Local routes have the highest priority, assuring efficient handling of traffic to the router itself. Last but not least, we have static routes. Static routes are manually configured routes set by a network administrator. They provide precise control over routing paths, ensuring traffic follows specific routes. Static routes don't rely on routing protocols, making them simple and stable but requiring manual updates. Ideal for small networks or specific paths in larger networks like secure or backup routes. Alright guys, so I went ahead and set up a quick simple topology for you guys. We'll go ahead and go into privileged exec and global config. We'll go ahead and bring up some of these interfaces. So we'll do interface GI000. We'll do a no shut, and we'll add IP addresses as well. So we'll do IP address 2.168.10.1, 255.255.255.0. We'll go ahead and use /24 all across the board. All right. And a bad habit of mine, sometimes I don't name my devices. So we'll go ahead and get that started now. MBR4, I guess. I don't know why it started 3, 4, 5, 6, but whatever. All right, we'll go interface GI000. IP address 192.168.10.2, 255.255.255.0. Then from here we'll go, we're not going anywhere before we do a no shut. Then we'll do interface GI001, IP address 2.168.20.1, 255.255.255.0. We'll do a no shut here as well. Okay, so that's 20.1. My next one, GI000, is going to be 20.2. Config T, host name R5, correct? Yeah. Nope. Interface GI 000. It's really easy to get ahead of yourself when you're configuring devices. Yeah, so sometimes you want to slow down. You know, you'd rather be right slow than fast wrong. That's what I'll say. Interface GI 001. Naturally, you want to be right fast though. That's a you want to be right fast. Interface GI 001. We'll do a no shut here, and then we'll add the IP address 192.168.30.1.255.255.255.0. Okay. Last but not least, we'll go ahead and do our last interface over here. So host name. See what I mean? Real easy. So we'll slow down, go to host name. We'll do interface GI 000 IP address 192.168.30.2.255.255.255.0. Alright, we'll do a quick check. Make sure everything's in the right spot. I forgot to do a no shut here. So go ahead and do a no shut. Alright. So we'll label it 192.168.10.0. This is going to be the network address for this network. .20.0 and 192.168.30.0. Alright, so we got the 10.0, 20.0, and 30.0 network. Alright, now we'll go ahead and take a look at the routing table. Alright, so we'll do show IP. It would really be show IP route, but sometimes with Cisco, if you want to, cut out a letter or so, most of the time it doesn't, kill the whole command, right? But as you can see, we do have connected and local routes set up. All right, so we've got local routes for the specific IPs of the device, and naturally we've got connected routes for our actual connected interfaces. All right, now we can go ahead and ping 192.168. Let's say 10.2. Okay, that worked, right? Now you're probably wondering, why did that work? Well, it's because these two devices are connected to each other. We've got 10.1 right here, and we've got 10.2 right here. It's as simple as going to your neighbor's house for a cup of sugar. Your router knows how to do that. But can we ping over here? Let's find out. 168.20. As you can see, a success rate of 0. My pings have failed. I gotta make some changes. And I know exactly the change that we're gonna make. We're gonna go ahead and add in a static route. All right. So here's how we'll do this. We'll go into global config and we'll do IP route 192.168. And you want to do destination, the subnet mask of the destination, and next hop. So we want to get to 20.0. Yeah, we want to get to the 20.0 network, so we'll do the network address of the 20.0 network. We'll do the subnet mask of the 20.0 network, and then the next hop 192.168.10.2. It's gonna be 10.2. Next hops essentially work like a let's say example, a layover flight, right? Let's say I wanted to fly from, right now I'm in Jacksonville, Florida. If I wanted to fly to, let's say Japan, right? All the way on the other side of the world. But I had to stop in France in order to do so. France would be my next stop, right? So if we're trying to go from Jacksonville all the way to Japan, we need to stop in France. Simple enough. All right, so go ahead and add in the IP route command. We'll do end, and we'll try this ping one more time. And as you can see, the pings work perfectly. Yeah, so naturally, I will give out a warning when it comes to static routes. They are prone to user error, right? Most of the time, dynamic routes are usually going to be the way to go. I'll cover dynamic routes in a separate video, but static routes are fantastic when it comes to getting down the concept of routing. You know, they're fantastic for small networks, simple topologies, something like this, just going from network to network to network, you know, something small and extremely manageable. Hey, a static route to your heart's content, you know. All right, so we'll go ahead and add in all of our other static routes. So we want to get to the 30.0 network. We'll do 25.25.0. Then next hop, remember, it's gonna stay the exact same. 199. Whoa. All right. What am I missing? That's what I'm missing. What am I doing? Why am I in privileged exec trying to do this? Hey, you know what I can do? I can go ahead and copy this. And then, no, that's not what I need to do. I can do IP route and just paste it. Just like that. Yeah. Little lazy act when you know what you're doing. Naturally, static routes are something that have to be configured on almost every device that's not directly connected. Because how are they going to speak to each other? They can speak to neighbors, but speaking to the device after the neighbor, routers are not advanced enough to do that, as far as I know, anyways. So we'll do IP. Why'd I keep clicking on IP route? Playing too much arc raiders. That's what I'm doing. You don't click go in arc raiders. And that was a fib by me. We'll do in the 20 dot network. So we'll do 30. 192.168.30.0. And we'll do next hop 192.168.20. Is it 20? It'd be 20.2, right? Yep. 20.2. Alright, so a way I like to do my static routes, I like to summarize them. So instead of making a route for all of these different networks, we can just go ahead and do IP route. Let's say .0.0. And this is why subnetting is important, right? Because usually it's a 24 network. So that means anything in the 30 network, whether it's 30.11, 30.60, 30.66, 30.40, whatever I've got, configured in the 30 network, it's gonna work. But if we summarize it to be a /16 network and update the subnet mask as well, that means everything that starts with 192.168 is going to be able to speak to each other. which will be perfect. So go ahead and do IP route. We'll do the destination. You set them as next hop. It's going to be the same. Next hop is always going to be the same. All right, and what we'll do, we'll copy this address and we'll paste it on everything. We'll have to change up the next hops though. That's what we'll do. You should be 20.2, right? Yep, 20.2. Alright, we'll go ahead and paste here. I added 20.2 as a static route. That's exactly what I mean. When I say static routes are prone to user, this is wrong because 20.2 is not the next hop for this router. It's not the next hop at all. The next hop is actually 30.1. All right, let's try and go ahead and. Uh-oh, what's that do? And as you can see, my pings work perfectly. Okay, 30 can ping 10, 10 can ping 30, and naturally, everything in between. If your ends can ping each other, then data packets have to travel through the middle to get to each end, right? So if the ends can ping each other, it's pretty much a done deal. Right. But yeah, that is going to be my first video on static routing. I do hope you guys learned something. You know, networking is extremely important in today's society. It's how devices speak to each other. You know, where would we be without it? We'd be in the dark ages, right? So naturally, network engineers are needed. If this video helps somebody, that means I've done my job. You know, if I can obtain the knowledge and share it, hey, why would not? Yeah. But it's Rod the Tech God. This was my routing video, static routing video. I'm not too sure what I'll name it, something along those lines. But I hope you guys enjoyed, and I will see you all in the next one. See ya.